Hello and welcome, everyone. It's the top of the hour, so we're going to get started. And don't be alarmed as more faces come in and join us. I'm so excited you're here for the fourth Meet the Inventor event from IDiyas, the inventor and patent insight platform built by inventors for inventors. If you haven't visited the IDiyas website yet, please do. It's full of fascinating insights about inventing and innovation from big data. My name is Madeline Key, and I've been interviewing inventors for more than 15 years. Before I introduce our esteemed guest, inventor Michael Fripp, distinguished engineer at Halliburton with over 400 patents, I'd like to thank our sponsor, Inventors Digest. Inventors Digest is the magazine for idea people. Now in its 32nd year, Inventors Digest is committed to educating and inspiring independent and professional innovators. Michael, we're thrilled to have you here with us. Bear with me as I read a little bit of your bio. Michael Fripp is a prolific inventor and innovation leader living in Singapore. He has created a broad range of innovations for the energy industry. He holds over 500 awarded and pending US patents, many of which have been commercialized. He is a collaborative inventor of autonomous inflow control devices, dissolving hydraulic fracturing tools, acoustic wireless telemetry, and expanding metal alloys. His innovations have become disruptive improvements in downhole oil and gas production and are enabling improved carbon sequestration. World Oil Magazine recognized him as an innovative thinker. Dr. Fripp earned MS and PhD degrees in aeronautics and astronautics from MIT and a BS in engineering science and technology at Virginia Tech. He's a licensed professional engineer, authored numerous technical papers, and co-authored 4 books. So I know many of you prefer to leave your IDiyas screensaver up and your cameras off, but part of the fun of the YouGo platform is seeing your faces, so please feel free to turn your camera on. We'd love to know where you're attending from, so please write into the chat box, which you will need to click to open at the top of your screen on the right-hand side. And finally, I've prepared questions for Michael, but we'd really also love to hear your questions, so please write them into the chat box. We won't be able to get to every question, but we'll do our best. And this is a special 45-minute episode of Meet the Inventor. So we'll be getting to even more questions than typically. Okay, Michael. My first question is one I really like to ask inventors because I tend to find the answers very interesting. Do you think of yourself as an inventor, and why or why not?
I generally have not thought of myself as an inventor. I tend to think of myself as a problem solver.
Mm,
That
that makes
there
sense.
are really problems to be solved, and then there are some, and finding the solution is, you know, what I do is just the very beginning of it, and that there's a whole lot of innovation that has to come along the entire process. That just coming up with the direction is, in my mind, the easy part. But there's a whole lot of inventing that has to be done, from taking it from concept to reality. That there's a lot of inventing that has to be done in the development of the project, as well as in the commercialization. That the inventing doesn't stop when you go and get your patent.
That's such a great point. I feel like it's a more of a stake in the ground for where you've begun, let alone continuing to innovate after something has been commercialized and improved. We're going to talk a lot today about commercialization, which I'm extremely excited for, because I agree, if an invention can't be commercialized or isn't, that's not as useful to humanity. I loved how you shared how you began learning about intellectual property. So I'd like to ask you that. When was that?
So, to an extent, I have known from an early age the value of protecting intellectual property. My father spent a career doing microgravity crystal growth with NASA. He got his first patent through NASA when I was 9 years old.
Mm,
My in middle school, I wrote some software, a computer program for educational software used in the public schools, and I went and applied and got awarded a copyright for that software. So the
Mm.
idea of protecting intellectual property, I've known for a long time, but that's different from really knowing patents. You know, the patents are its own beast there. And I
Yes.
really didn't learn the essence of patents until I came and really worked for Halliburton. That I've had some very patient coworkers who have been able to teach me the the essence of patents. You know, what is worth patenting? How do you
Mm.
go and take what you
Mm.
have as this broad concept, and how do you distill it into a patentable concept?
Mm.
And how do you go and take something, you know, a lot of engineering is inherently design,
Right.
but patents are inherently words. And so how do you take
Mm.
something that's, you know, this part's connected to that part and express what is unique about it in words is really is a trick. It is a skill that I had to learn as well.
Mm.
And so people like Roger Schultz and Syed Hamid were very patient in teaching me this.
Mm. You said a couple of interesting things here. What I've heard is that it's really valuable to include a lot of drawings in a patent application, partially for the very reason you just described. Has that been your experience?
Yes, and so there's part, you know, so what you have to do to make a good patent is that you have to convey, to express how what you have has never existed on the planet before.
Mm.
And so
Mm.
part of how you do that is through words and, you know, your verbal skills and being able to articulate what the essence is. And part of it is in drawing. And it's not, you don't really want an engineering drawing because that
Mm.
sort of confuses of what you're trying to say. That really what you'd love to have is more of a, you know, a pencil and pen drawing of
Right.
the essence of the invention. You know, how can you reduce down
Mm.
this complicated system into the essence that you're trying to invent? And so,
Mm.
yes, you know, the drawing. So it's not so much CAD skills as it is
Mm.
the creativity of being able to draw it out by with magic markers.
Sure. Um, I've tried reading patents. I enjoy reading patents, but dang, there's this barrier. I think of someone who's not sure what it is, opens up a patent and just wants to maybe toss it away because the language is maybe impenetrable almost. I enjoyed hearing you talk about how you've worked with maybe patent attorneys to learn about, of course, how to write a patent application, but also patent examiners have taught you a lot. Can you help us explain that? Because I don't think that all inventors are seeing the office actions, but I think that they should be.
So let's go sort of work through what the steps of getting a patent are. That, you know, so the first step in writing a patent is that I will go and do experiments in my lab to
Mm.
come up with something that I think is new and novel. I will write an invention disclosure, which is basically a 3-page document that will that describes the essence of the patent. I'll work with my coworkers,
Mhm.
so people like Stephen Gracie or Chopin Dave, to go and help craft that invention disclosure.
Mm.
And then I'll work with the outside attorneys. So Scott Teakle and Greg Peacock are some two excellent outside attorneys that I've been working with most recently that will help
Nice.
take that disclosure and make it into a patent application.
Mm.
And then the examiner will come back to us and tell us why it's not, why it should be why they consider it somewhat obvious, and we'll have to go and argue with them and help refine what our claims are to make it clear that what we have is, it's not obvious, it's novel. And when
Mhm.
you go and get the response back from the examiners, it's a long document. They put a
Mm.
lot of effort into reading that patent application, understanding that patent application, and then
Mm.
comparing it to all the all the patents that have come before us, and they will go and combine different patent applications,
Right.
different patents from the past, to go and say, you know, you think you've had something new, but if you combine A and B, that maybe it's not so obvious. And
Right.
from the examiner's description, responses, yeah, there is, I've learned a lot in terms of, things that seem obviously novel.
Mm.
When you go and look at it in a slightly different way, you go, oh, I see where they're coming from. That the examiner is often right, and you go and have to reframe and refocus. And more importantly, when I write my next patent application, I remember what the examiner found fault with in the
Mm.
previous patents and can use and build from that. So, yes, I learn a lot from the patent examiners.
Mm. I love that. You're almost like you're getting this insight look into a different way someone thinks. So it seems totally plausible how you might reapply that different way of thinking to maybe even a future invention or a different problem you're solving, or certainly within the application.
Right.
Um, I believe you've brought or have with you maybe a couple inventions to describe. I'd love to hear which inventions you're proud of and perhaps which have made an impact commercially, so we can really kind of maybe better visualize what you've been doing and improving.
So, as an inventor, I tend to be most proud of the invention that is most recent. And this one is particularly fun because we discovered it by accident. So, we were working with developing a new metal, and we found by accident that this new metal, when you go and put it in water, will go and expand and
Wow.
almost double in size as you get it wet. And that was terrible for that initial application, but it got
Right.
us thinking, what that's something really unique. What can we do with it? And we were able to go with a lot of experimentation to go and transform this expanding metal into a downhole seal and a downhole anchor.
Mm.
So it's something that you can go and put on the outside of your pipe. When you go and put it in the well, your well bore is full of water, and so it will go and interact with that water and expand and turn into that rock-like seal and rock-like
Mm.
anchor and hold everything in place. And that's really important to be able to go and keep your an oil well, to keep your oil zone away from your water zone. Um, and I really think that this is going to have some really unique applications for geothermal wells, um,
Mm.
partially because of its temperature rating, and partially because in a geothermal well, especially in the enhanced geothermal, you're going to be injecting cold water and then letting it heat up. So you get these huge
Mm.
thermal cycles, and your thermal expansion on your pipe can get huge. And so if I have a really good anchor to hold everything in place, that's that becomes really important to making sure that the thermal cycles do not tear apart your geothermal well.
Right. What a big benefit. How long have you, if you could maybe help me understand, you said things are moving so quickly these days in the energy industry that the things you're working on 5 years ago are not necessarily what you're working on today. I'd love to know, if appropriate, some of that timeline. Is this kind of rapidly coming from lab to market? Is this taking years? Bring us to a ground level view, maybe. I think a lot of people care about what's happening in energy.
Right. So the energy industry is a huge industry. It moves everything,
Yes.
literally and figuratively.
Yes.
But so one of the joys of working with the energy industry, is that there are some places, North America land, for example, where the ability to go and innovate is really encouraged. That we have some
Mm.
operators that are
Mm.
really hungry for new technology and are basically hungry to go try things out. And so there we can go, and if I can have an idea 1 year, and within 18 months we can go from concept to going and getting it in a customer's wellbore.
Wow.
That that as we noticed in your intro, my background was in aerospace, and the idea that in aerospace you get about one or two commercializations per career. Here
Right.
in the energy industry, you can go from concept to implementation much faster. So
Mm.
that doesn't happen very often. You know, that requires the entire team to be focused on taking that product to market. And so, you know,
Right.
an inventor doesn't do that. It is, and it takes something like a Halliburton that's big enough that can
Right.
move and mobilize a team of people. And there are other projects that are slower. But one of the things that's really fun is that I can directly see some of my inventions having direct impact
Mm.
for how the energy market is being developed. That one of the I don't really want to talk. We're working currently on low carbon energy futures,
Right.
and it's not clear at the moment which one of those is going to which one of those is going to be the key. But it's more clear that leading up to this point, that one of the problems that you have with traditional oil and gas wells is not so much when you turn them off not so much when you run out of oil, but when you start to produce too much water. And so one of the inventions that I have is a device that can go and sense whether it is oil or water coming into the well,
Mm.
and it can go and automatically restrict the water and automatically let the oil flow, and it can
Mm.
do all of this with no moving parts. In fact, it's just this little device here that
No
when you
way.
have the flow coming in from the edges and leading out the center, that based on the fluidic pattern coming in here, we can go and
Just
if it
knows which
was
one.
water, it'll
Yeah.
spin, and if it's oil, it flows out smoothly and easily. And so it will go and increase the ultimate recovery of oil. So this autonomous inflow control device, there
Mm.
are reports by some operators that their ultimate recovery, the amount of oil that they can get out of the ground, has increased by 30%. And so
Wow.
that means
That's
fewer
massive.
wells, less wastewater,
Yes.
and um, um, you know, greater recovery. So but you can directly see that what you're doing has impact, and
Yes.
that's really validating.
I was going to say how enormously satisfying to see the effects of your work and be able to measure them in that way. Um, that's remarkable. I am losing my train of thought for a second. Oh, this is what it was. That looked very simple, Michael, but I suspect that was not simple to develop. Can you talk to us about that a little bit? Because there's this idea that simple is easy, but I don't think of simple that way. I think of simple as very brilliant, actually.
It is surprisingly complex to make something simple. That
Right.
the first prototype of this device, right now it's about the size of a matchbox car.
Yes.
The initial prototype was the size of a desk, and it it worked, but
Wow.
it would never have been commercially viable. And there's nothing more frustrating to an inventor to have a concept that is technically works, but is a business case failure. And so
Yes.
it was through a lot of experimentation, um, and a lot of CFD modeling with Jason Dykstra and Orlando De Jesus, and Stephen Gracie, to be able to go and condense that giant piece down to something this small. So yeah, there is a lot of engineering to be able to go and make that.
Right.
which is also a challenge because I have, when we're going to go and apply for a patent on our AICD, that means I have to go and put into words this design and what makes this design unique and special and work well. And so
Mhm.
this is one of the reasons you know, it's a challenge.
Yeah, it's a real challenge. Could you give us any estimate of how many patents that what you're holding there that were maybe involved in? Ballpark figure?
So the key with doing a patent is that you don't work for just one patent on one invention.
Right.
That there are, on this one piece here, there are a lot of different aspects to the design, from the design of the vanes on the inside, to the design of the entrance passageways, to its operation, to how you will use it, to, well, to some of the alternative designs that we evaluated but then rejected.
Right.
And so
Right.
what I'm looking to do is to not file a patent on a device, but to go and make a patent fence, a wall around it, to go and say, Halliburton claims this area and it's ours.
We're going to defend it.
Um,
Mhm.
and we're going to defend it. And partially, if there's just one patent, you can find a way around one patent. But when you have a whole wall of patents, it's communicating to your competition that it's something that we find important, and it's something, and it makes it really, really hard. It allows you to have that exclusivity with it that you are being granted when you are awarded a patent. So on the autonomous inflow control devices, there's about 30 different patents inherent to that. On
Wow.
the expanding metal piece here, we have about 50 different patents on that, because it's not
Wow.
just the metal that's expanding that we've wound up patenting, but the
Mhm.
different applications that we're going to be putting in, the different ways of triggering it, the different ways of accelerating it, different ways of slowing it
Mhm.
down. That there are layers of patent, and the patent strategy is important too.
Yes. Yes, let's talk about that for a moment. So, something my dad, Stephen Key, who is an inventor, likes to recommend when thinking about writing a patent application is to think about workarounds and variations. And he says, if you were someone else, how might, this someone steal this invention from you, like to put it right out there. And I think that's an important way for inventors to be thinking about patent applications. Not, I'm literally describing what I've invented, but taking it a step further and saying, how is this going to be used in a commercial sense? And you shared some really interesting questions that you think about when you're writing a patent application that I'd love for you to share, kind of what I bet you consider so much as part of that strategy, and whatever you can share, I know will be very appreciated.
And this is one of the things that I learned from the in-house patent attorneys, Bill and Wally and Paul Herman, is that when you're going, all right, so the patent has three main parts. One is the figures that show the pictures of what you're trying to invent and help explain it. There's the description that gives the text that sort of goes and helps teach the world what that new invention is. And then at the end, there are the claims. This is the pieces that I'm putting into words that I say, these are my inventions, and that the government is giving me a 20-year exclusivity on being able to produce products with that description.
Right.
Now, one of the keys on how you go and write your patents, and really on how you go and write your claims, is I want to be able to go and describe something that I can go and prove that a competitor is infringing, that I can go and prove that the competitor is violating those claims.
Yes.
And so if I can't see what the inventor is doing, then there's no way for me to know whether they're violating the claims or not. So, when when I'm making things out of electronics I tend not to patent the firmware, the software that's on the board that describes how the electronics is working,
Yeah.
because there's no way to really know um, what's in
If
the
someone else is
competitor's
using
firmware.
it.
The other thing is I want to make certain that I am patenting something that my competitor would be using and not something that my customer would be using.
Yeah.
So on this autonomous inflow control device, I want to patent the design of this. I want to go patent putting it on in a tool, but I don't really want so much to go and patent using it in a well. That if I go and patent on the tool, then that's what the customer will be doing. The customer is someone who will go and make tools. Using it in the well, my customer doesn't do that. That's what my that's what my customer does, not I got this backwards. Sorry. I won't go and patent putting it on a tool because that's what my competitor does.
Mm.
Putting it in the well for that's what my customer does, and I really don't want to have to sue my customers for infringement. So there
Right.
is challenge in terms of you know I want to go and claim an apparatus much more than I want to go and claim a method for doing something.
Mm.
Not that we'll also try to claim both, but it's we need to be careful to make certain that what we're claiming is something that we can work to actually enforce our claims and to enforce that.
Sure. To me, what I love that what you're highlighting is that innovation doesn't take place in a silo, that you have customers, you have other entities that you work with and are essential to your business. And that's the part of the business strategy of patents that I feel can sometimes be not as acknowledged as much, partly because what company really wants to come out and publicly and talk about its IP strategy? That's a bit of the secret sauce. That's where they're heading. There's so many insights to be gained. I have not heard an inventor describe it that way. And so I thought that was really salient and I appreciate you sharing it. Um, let's see. I want to switch gears a little bit here. And um, something that stood out to me a little bit, you've acknowledged you studied something very different for a long time. And I think sometimes maybe young innovators are very concerned about what they should study. So I'm curious, how important is subject matter expertise? And do you have advice for really that question of, I want an exciting career like Michael's. I want to be inventing things that matter. Do I have to study engineering? Can I study something else? I'd love to learn a little about that.
So, my degree is in aeronautics and astronautics. So I've gone from working with rockets to now working with rocks. But the advantage of engineering and science study is that the issues are really similar in almost all of the application domains, that the
Mm,
issues of a couple miles up or a couple miles down are really very similar, that you know comparing satellites and oil wells, it's all about power, size,
mm,
and reliability.
mm,
um, that if I break a satellite or I break an oil well, it's really about the same number of dollars, and they're both about equally easy to go and retrieve and to repair. The difference, but there are clearly are differences. That satellites also Im- immensely care about how much things weigh, whereas we have a million
mm,
pounds of steel on our tubing string.
mm,
But the real key is to know, to have a domain of knowledge and to be able to build from that. And so,
mm,
for a young inventor, part of the key is to be curious about, everything,
mm,
to know, that a lot of what I do is to go and bring together technologies from different industries. That,
mm,
part of the swellable metal technology was adapted from marine biology. That part of the fluidics technology inherent to the AICD was adapted from aerospace type and automotive technologies. That
Mm,
it's all a lot of the innovation is at the intersection of different technologies and finding what you can go and take from different places and put together. Um, so, to an extent, I was hired into Halliburton because I was not oil field. They were looking for somebody who would sort of not be constrained by the normal design
right.
paradigms. And
Mm,
so a lot of my ideas initially were not really grounded in reality. And
mhm,
so
mhm,
yeah, I had some very patient coworkers who helped guide me towards practicality, but that not necessarily being constrained by reality is useful for helping to evaluate the what ifs that that you have something that you can't do that, Michael. Right, fine, but if we could, what could you do with it then? And
mm.
enables evaluating different concepts that have led to some really neat inventions.
Yeah, so it was really an asset to the company that your deep subject matter expertise was not explicitly that. It was maybe you were more open to ideas. You were going to look externally as opposed to referencing that body of knowledge you already knew. So a takeaway for me is there's no right or wrong STEM subject to get involved in. You're going to amass the skills that you can apply, um, which leans right into our next question. So I love what it sounds like you get to do these days as a distinguished engineer, in that you collaborate across industry, academia, national labs, and customers to innovate the next disruptive technology. So, what does that look like? Are you finding people that you think might be able to help on LinkedIn? Are you having calls with your customers? Are you traveling to meet other academics in person? Like, how does that really play out?
Right, so you can't invent everything that, and really the easiest thing to do is to find technology from other industries that other people have already developed, and figure out how to go and commercialize it and apply it in your industry. So, the
Mm,
national labs, the universities are great at sort of incubating technology and getting it built. And then the key is Halliburton and me can go, and I can go and help them take their ideas that originally developed for automotive applications
mm,
and help bring that into oil field applications. And Halliburton actually tends to be a pretty good partner for for small companies that we we play nicely with others, and you know we work hard for it to be a win-win with everybody. And
mm,
one of the other advantages of a company like Halliburton, with an oil field energy company, is that we are used to working with small quantities. So we can work with some early prototypes, and we don't have to have, you know, a billion products coming in on the market and have every dollar squeezed out before we can start doing commercialization. That we can do commercialization when you're still having the PhDs going and wiring parts together. And
mm,
that's really kind of unique. Um, that there are some, if I'm putting in an airplane, you really can't experiment with it. But there are a lot of wells where there are pieces that there are customers who can go and will be willing to work with you on new technology, um, that has not yet been proven out,
mm.
and
It's a
that
very
there are other
experimental.
applications that it has
Yeah.
to be bulletproof, will have that will take it from those initial customers and then work with us later. And so, that a lot of the operators are explicitly have programs to help the Halliburtons of the world go and incubate the technology, um, into their applications too.
Mm, fantastic. Um, I think in the independent inventor space, there's this sense that inventors have to do it all alone. And I don't see the emphasis on collaboration that's coming through so loud and clear in the corporate environment. Do you have advice for how an innovator can become more collaborative, or any tips in that realm?
Yeah, I used to, I have always been really good at starting projects and coming up with new ideas. That's just something that's how my brain is wired. But then after a year or so, I would tend to lose interest in them, and to an extent, I had thought that a, a downside. But one of the advantages of working in a larger corporate environment is that there are development teams. There's a research and development team then a commercialization team, and then an operations team. That
Mm.
there's this whole pipeline of people who are set up to go and take the ideas and those prototypes and transform them into things that will help our customers. And so that's really nice. And so as a result, you know, to an extent, I have the freedom of a wide range of different research areas without having to worry about writing grants. Um,
Right.
but so, but the key then is that you have to go and find your team. That you have to
Right.
go and find your people. As engineers, we like to pretend, we like to say that math is hard. I'm sorry. As engineers, we like to say that math is easy and people are hard, but it is the people that allow you to succeed. And so the key is to go and find your team, build your team, find the people with whom that you can work and um, help, that help you, that understand you, and then it can help translate the plumbing pipe and duct tape prototype that you're so excited about into the hard metal commercialization. But even in the individual inventor world, that you will go and need to have, the individual inventor can come up with a concept, but they will go and work with a team to go and help them commercialize it and go and make it a real product. Even
Right.
in the individual commercial inventor world, you have to find and build your team. That
Absolutely. Yes.
it's not a solo endeavor.
It's more fun that way too. You can feel that lift. Um, I see that Colin Stathis, I apologize if I'm not pronouncing your name correctly, has asked a great question. On our pre-call, you mentioned that a lot of what you do in inventing is really problem defining. And he's asking, how do you decide which problem to address?
Right. So by definition, a patent has to be useful. It has to be inventive and novel and useful. But we all know that some inventions are more useful than others.
Right.
And so I work hard to avoid, I think about the application from the beginning, that there are a lot of ideas, but for it to be useful, it has to be practical, it has to be implementable, it has to go and solve somebody's problem. And so that
Mm.
I think about those problems from the beginning. And so to a large extent, I think of myself as having a toolbox of concepts that I'm trying to find a home for,
Right.
and a whole nest of problems that I'm trying to solve. And it's all about going and finding that handshake between those two. So yes, really the hardest part is not the ideas, but the hardest part is defining the problem such that a solution is possible. And
Mm.
so you can't really define the problem until you know what solutions can possibly exist. And so it's
Mm.
that combination that's important. This requires the inventor to know the application. It requires the inventor to talk with customers. It requires the inventor to have a sense of of what the customer's pain points are, what their alternatives would be. It requires the inventor to actually talk to people outside the organization.
Yes. Yes, that makes so much sense to me. That seems like it's so common among inventing that there's something that will be conceived of and an inventor will get excited about. Understandably, it's new, it's novel. And then there's that latter part, which is figuring out, does someone actually need this? Is there a market for it? And what that's really asking is, couldn't this drive some economic value? As in, this problem, you're going to save me time, you're going to save me money, that will have a tangible impact on your customers. So I think that's a great question. We have another good one from Jacob Fripp. Earlier, you mentioned something along the lines of finding something that works in the lab, making a discovery, but doesn't have a meaningful market value. What do you do with those type of inventions? Will you patent them or find someone else who might want to patent them, or how does that work?
So there are some there's a running joke among the engineers that Michael is always looking to go and find applications for a series of these products, a series of these ideas in my toolbox that I will find a way to use it eventually, but I haven't found it yet. Sometimes I'll go and patent them early on, especially if I see a path forward. But mostly I will sort of keep them in my toolbox waiting for that killer application, waiting for how we're going to go and use them. So yeah,
they're still with you. It's just that you haven't found a home yet. It's not that they don't have market value. It's that you haven't found it.
Right. Orphan ideas that are waiting to get adopted into a new product. Yes.
I love it. I think every inventor feels the exact same way. Shale Lewis has a burning question for you. What do you think about the viability of deep geothermal and the possibility of piping molten salt as a medium of thermal capture?
Yeah, I'm a research guy, so I can go and tell you whether we can make the technology do this. But when you start to go into deep geothermal and molten salt, the real challenge with that is the economic viability. That when you go and start doing the deep geothermal, the challenge there is how much energy are you spending pumping the fluid around versus how much energy do you get out of it. And the challenge with the geothermal is that there really just isn't that much energy in hot water. And so it takes a lot of hot water and you have to produce it very efficiently before it's a viable product. That the easy geothermal, the hot rocks that are close to the surface, they've already had geothermal plants to them. So now it's the question of the deep geothermal, and that gets an expensive well to drill and an inefficient thing to go and pump that fluid around. And when you start to put molten salt in it, which tends to be very viscous, and the molten salts tend to be very expensive, and if you stop pumping and the salts freeze up again, that gets really hard. There's just actually what it means is there is a lot of space for more inventions and more improvements to go and help make that space become commercially viable. That is definitely an area that there is a lot of work being done in currently. But it's a hard one to go and crack.
Great answer. We're getting close, unfortunately, to our last minutes with you here. And so I'd like to end by asking, will you share some of your advice for young innovators?
The key advice I would have is sort of twofold. One is internally, that to go and if you want to be an inventor, the key is to be curious about everything, to go and learn not just your one domain, but all around it, to go and work and talk with the people from marketing, from to machinist. That, at Halliburton, we have a Toastmasters speech making group, and that is a fabulous way to go and figure out what the left hand and the right hand of the company are doing, and that you meet people there. And so, find the, if not Toastmasters, but the equivalent group within your organization to go and be able to go and connect across disciplines. That my friend from the other half of the company has been really helpful in understanding, what's happening when I have this material that's expanding. That it's really the cementing guy and my chemistry guy over here can go and help me understand it. So it's that being curious. And the other key piece is to go and create your team, that you're not going to do it all yourself, that your inventions are better when you collaborate with people in the writing and drafting and inventing of your patent. And your team is important for going and helping you to go and transform that invention into commercial practice. That you are one piece, and one of the joys of being the inventor is that you happen to be at the front end, and so your name gets to be on the patent. But there's a lot of invention and a lot of creativity that's required all along there. And so to find your team and work with it along that entire process.
That's fantastic advice. As our meeting has drawn to a close, please, everyone, if you would share your appreciation for Michael in the chat box, give him a thanks, let us know what you thought of our conversation. I'd like to thank you all again for joining us. You can provide feedback to me directly on LinkedIn. You can also email support@idiyas.com. And really, Michael, this has been absolutely phenomenal. Thank you so much for educating us and inspiring us. It's really been a pleasure.
Thank you.
Phenomenal. Okay, everyone, we'll see you again soon.